Hi everyone, and welcome to part 2 of activity 11. Today we are going to talk about polynomial inequalities. So as we look at a graph of a polynomial function, we want to be able to analyze and say, okay, where is this graph greater than 0, aka above the x-axis, or where is our function less than 0, aka below the x-axis? So if we look at our picture, being greater than 0 above the x-axis is happening officially in 3 places on this graph. At first, it's happening from negative infinity until we get to a 0 at 1, 2, 3, negative 4. And then it's also happening from the range from 0 to 2 over these x values. And then finally, from that last 0 point at 6 to infinity, our graph is greater than 0. Our graph is then less than 0 below the x-axis in those kind of intermittent points then from negative 4 until we get to 0, or from 2 until we get to 6. It's below that x-axis. And where these changeover points keep occurring, we notice, is at those zeros, right? At x equals negative 4, 0, 2, and 6, each time are where that changeover is kind of occurring. And so what we kind of are noticing here is that we have particular critical values that we see these changes taking place at. Now, a critical value is a value at which the function is either equal to 0 or where it is undefined. Now, right now, what we're noticing is we don't have any pieces on here that are undefined, but right now we're focusing on those times our function is equal to 0 for our critical values. And if we flip to the next page, we see here a little bit more how we're going to actually be able to look at these, and that's with a sign chart. So what we do with the sign chart is we make a number line, and we put all of those critical values on it, again, this time the zeros, and then for each interval between those critical points, we pick a number and plug it into the function, and then we're either going to put a plus or a minus over that interval accordingly to talk about, okay, where is this above the x-axis versus where is it below the x-axis. So for instance, if we see on this chart here, we start with our sign chart, okay, we have 1, 2, 3 different zeros, 1 at negative 3, 1 at 0, and 1 at 4. And when we look at these pieces, we want to say, okay, where is my graph above the x-axis? Well, that is from negative infinity, so we get to negative 3. And then it bounces back and stays positive. And then for a little while, it dips below between 0 and 4. And then we're back up above the x-axis from 4 to infinity. So this would be our sign chart this time. And we want to talk about then, okay, where now over which intervals are we greater than or equal to 0? Okay, well, that is officially happening from negative infinity all the way until we get to 0. Our graph is greater than or equal to 0. And notice this or equals to allows us to put a bracket with that 0. Or that is happening, again, bracket 4 to infinity. Infinity and negative infinity are never getting that bracket, even though we are including on that. So then our less than range for this is only happening where we see that negative piece. So from 0 to 4 bracket, because again, we're including the zeros this time, is where we are less than 0, aka below the x-axis. We are, again, greater than 0, but notice no or equals to sign this time. This is where we have to be kind of careful because we're greater than from negative infinity until we get to negative 3. But because we're not including negative 3 this time, it's going to be a parenthesis. And then from negative 3 to 0, again, we're above, or from 4 to infinity. So notice the difference between this first one where we included the zeros. This time, because we're not including the zeros, we actually kind of broke this up and had 3 different intervals instead. Now, less than 0, not including 0, is again 0 to 4. This one was only changed up because we aren't including the zeros, so they just changed to parentheses versus brackets. So again, if we look at some of these pictures, we want to say, okay, where is this particular graph less than 0, aka below 0, and we're not including 0 this time. So we have a 0 here at -6, and then we have another 0 at +1. So from -6 to +1, those x values, we are less than 0. And notice parentheses this time because we're not including the zeros. We are going to be greater than or equal to 0 then on 2 different intervals, from negative infinity until we get to that 0 at -6, including that, and then from +1 to infinity. So again, notice that or equals to made us use brackets with our zeros. All right, there is an example for you to try down here. Over what intervals are you greater than or equal to 0? Now, on the last page, we see how are we going to actually do this then without a graph being involved. Okay, so this is where we're going to have to start by looking at a little bit of factoring and finding where are our zeros. So notice on this one, they didn't give this to us in factored form, but we're going to say, okay, what multiplies to be A times C, aka 144, adds to be our B term in the middle of -24. Well, that's going to be this time -12, and -12 would multiply to be +144, add to be -24. So since we have a coefficient on our leading term here, in this case, we have 9x squared. So we're going to have to break this up and group before we can actually solve. So each of these can have a 3x taken out in this first one. So we're left with x minus 4. The second group, we could take out a -4 and 3x minus 4 for both of these then. Plus 16. So then this would be a minus because we took out a -4. So these match, and we see that our zeros this time are actually the same. It's 3x minus 4 and 3x minus 4 are the factors for both pieces, which means when we solve, we have 1 0 at 4/3 if we set that equal to 0. And again, since we see this twice, what we know is as we plot it on the number line, what's happening is that 1 0, we actually are going to see a bounce at. And then there'll be a multiplicity here because we see that factor 2 times. We know then that there's going to be that bounce there at this 0. Now, to double check, we can always plug in some test points, and whether you plug it into the original or your factored form, but if we plug in something that falls on this interval over here. So let's say a number bigger than 4/3, which is a little over 1. Let's test the number 5. If we plug in 5 as our x value to this original equation, we would have 9 times 5 squared minus 24 times 5, and then plus 16. We get a positive number so that we know this is a positive interval. And then if we test a number that is less than 4/3, so let's say we test -5, because we know that that would be on that range as well. We need parentheses around this before we square. Minus 24 times -5, and then plus 16. We see, again, we get another positive number. So this one's basically going to bounce back at our 0. Now notice on this, we are not including the 0. So a lot of times we like to represent that with an open circle so that I know, okay, where is this greater than 0? Well, that's actually going to be everything, just not the 0 itself. So from negative infinity until we get to our 0, we're above the x-axis, aka greater than 0. Or from that 0 on to infinity, we also see that we are greater than that value. So this would be our final answer for those intervals. All right, the next one, we have to factor again in order to find our zeros. So this time when we factor, we are looking at, okay, what multiplies to be a times c, aka 80, adds to be our middle term here of negative 21. This time that's going to be negative 16 and negative 5. That multiplies to be positive 80, adds to be negative 21. So we see again that we're going to have to break this apart because we have an a value other than 1. And when we group this time, we see that we could take out a 2x from the first group. We're left with x minus 8. Take out a negative 5 from the second group. Again, left with x minus 8. So 2x minus 5 is a factor, and the x minus 8 is a factor, which means our zeros this time, if we set each piece equal to 0, are going to be at 5 halves and 8, or 2.5 is another way of writing 5 halves. So on our number line, all right, we are going to plot those values. So we have a 0 at 2.5. We have a 0 at positive 8. So we have a couple different intervals to test this time. Okay, so if we pick a number this time that is smaller than 2.5, let's say 0. If we plug in 0 to our function this time, 2 times 0 squared is 0, minus 21 times 0 is 0, we'd be left with 40, which is a positive number. If we plug in this time a number that's between 2.5 and 8, let's say 5. So if we plug in 2 times 5 squared minus 21 times 5 plus 40, we actually see this time that we're getting a negative value. So that means that this would be below the x-axis. And then last but not least, if we pick a number bigger than 8, let's say 100, because that's bigger than 8. And if we plug in 100 for our value here, what we're going to notice is that we are going to get a really positive answer. In this case, 17,940, which again is a positive number. So that means that we are above the x-axis. This time our question is asking us though, where are we less than or equal to 0, aka that negative region. And we will include the zeros this time. So we would bracket and we would say from 2.5 or 5 halves until we get to 8, our graph is below the x-axis. All right, last but not least on this final example that I want to do with you, we are going to start by grouping on our first example here. So I'm going to take out an x squared from this first group. I'm left with x minus 7. I'm going to take out a negative 1. I'm left with x minus 7. So my two zeros this time, or excuse me, 3 actually, officially. My two factors this time are x squared minus 1 and x minus 7. So if we set each of these equal to 0, for this first one, what we are going to notice is that we are looking at where is my graph equal, x squared equal to positive 1. So x is going to equal positive or negative square root 1, which is just 1 when we set that equal to 0. And then my other 0 is going to be at x equals 7. So when we place these on the number line, I have negative 1 coming first, positive 1, and then 7. And then I want to check out my sign chart again. So if I plug in a number less than negative 1, so let's say negative 2, and again, be very careful of how you're using your parentheses here, but I would plug in negative 2 to the third power, and then minus 7 times negative 2 squared, and then minus negative 2, but plus 7. And we find out that we have a negative answer here So we end up with this region being a negative for that. And then from there, we're going to plug in a value between -1 and 1, so 0, for instance. So actually all of this will cancel out, and we have a positive. And then between 1 and 7, we could plug in a number like 3, because that is a number that will fall in between 1 and 7. So we plug in +3 for our x value. And what we notice on this one is that we get another negative output. And then if we plug in a number bigger than 7, let's say 9, this time we end up with presumably a positive, but we got to always double check. And we see that we do have indeed a positive output, so it'll be above the x-axis. So what we see then is we want our answers to be the regions where we are greater than or equal to 0, aka the positive areas. And again, we are going to include the zeros this time to close circles. And anywhere we see a positive, we are going to shade. And so my regions this time between -1 and 1 were greater than or equal to 0. And then from 7 to infinity, bracket this time, because we are including those zeros. All right, there is one last one for you to try. Thanks everyone for watching. We will look more at our examples in class.